Hi, I'm Bob Tabor with LearnVisualStudio.net. As I stated at the outset of this series of lessons, half the battle to learning how to develop apps using C# and .NET is first of all, learning the C# syntax itself. And then secondly, learning how to utilize the .NET Framework class library. When referring to the Framework class library, I emphasized that it had another name that it was known by as well, the base class library. And I'm going to explain why that's actually kind of a very interesting way to look at the library as a series of base classes. We're going to talk about what a base class is. We're going to talk about inheritance in this lesson. So let me come at this from a slightly different perspective. You'll see that I have a new project called Understanding Inheritance. And what I've done is just copied out some of the best parts from the previous lessons. We have a car class with some properties. I have a method called printMe. In my static void main, I create a new instance of my car class. I call this helper method called sum method, and so on. Okay? Now, back to the car class itself. Let's suppose for a moment that the car class is great for cars, but we need a slightly different implementation for trucks. So in some ways, cars and trucks are the same, and in some ways they're very different. I suppose what I could do is just copy all this code and then paste it right below it, changing out the word car for truck, so it makes it almost identical to the car class. But if I do that, I'm going to have a couple of potential problems. First of all, it violates one of our rules that I set forth a little bit earlier in this series, to never write the same code twice and to never use copy and paste. In fact, I said it was the sworn enemy of the software developer. It's not just a matter of having twice as much code to maintain, although that certainly would be the case. Think with me for a moment. If we just copy and paste the code and it's buggy, then we're going to need to fix that code in 2 or more possible places. Okay? Or if we rewrite the code from scratch, that's performing essentially the same logic. However, we weren't careful to implement that logic exactly the same, then we're going to need to fix that logic potentially in 1 or more places. And that could potentially be kind of difficult to hunt down and fix. From experience, trust me, I can tell you that that is a bad situation. Secondly, our application may need to deal with both car objects and truck objects. So we'll have to create 2 versions of every method that formerly accepted car as an input parameter. So in this case, here I'm accepting car as an input parameter. Does that mean I'm going to have to now create a second version of this method that only works with trucks? Well, that's not ideal, because what if we in the future want to add motorcycles or buses or things of that nature? So ideally, we could merely borrow the things about a car that make sense, then overwrite the parts that don't make sense, and then add parts that trucks need that really specialize it from the things that cars need. Trucks might need things like bed size or towing capacity, so we could add those features into the truck class and specialize it. So we can do this by creating a truck class and have it inherit from the car class. So let me show you what I mean by that. So class truck, and then I'm going to use the colon on my keyboard and then use car and then open and close curly braces. Okay, so now you might ask yourself, well, what do I really get by doing this? Let's come up here, and I'm going to go truck, my truck equals new truck. And then I'm going to go my truck dot, and notice, even though the body of my class is empty, I still get all of the properties and methods that I created in the car class. Why is that? Because car is the base class, and I am deriving functionality from that in a new class called truck. Now, so let me just do this. Take a moment here to flesh out this example. Now let me do this. Because a truck is different than a car in some small ways, let's add and specialize the truck class by doing this. Prop, tab, int, towing capacity. All right, and if we do that, we can come back up here and go my truck dot towing capacity. 1,200 units of towing. I don't know what that is. Okay, so at any rate, we have now specialized it. Is that available to the car? No, car doesn't have towing capacity. It's not available. So we have made a specialized version. We get all the best things about a car, but we're able to add some things about a truck. The other benefit that we get is this. Let us do some method my truck. And let's go ahead and run the application. And you can see that not only do I get this to work with my car, but now I get to print out the make of my truck as well. How is that possible? Because truck is a type of car. And there's a couple of different ways that this is explained, terminology that's used. What I prefer to use is that car is, in this context, the base class, and truck is the derived class. You'll also see it that car is the parent class and truck is the child class. And you'll also see that car is the superclass and truck is the subclass. And there's maybe even some additional ways that you'll see it referred to. Over the years, there have been a lot of different terminology developed to describe the relationship between the base class and the derived class that inherits from the base. But most importantly for our purposes, we want to talk about how the .NET Framework class library is just one massive collection of base classes and derived classes. And why is that? Well, because it creates this flexible way of working with classes in the framework. So let me give you a quick example of that before we continue on with our example here. We worked with the stream reader class. Do you remember that? Back when we were trying to access a file and we wanted to pull in the rows of data from the file and then print them to a console window. We were using the stream reader's constructor by passing in the literal string values.txt. That was the file name that we wanted to load up into our stream reader. Now what you didn't see was behind the scenes, the stream reader was creating a file stream object using that literal string values.txt. And so if we take a look at the file stream class, we can see that it has a class hierarchy, an inheritance hierarchy. Here is our system.io.filestream class, and I'm looking at this in MSDN, which is Microsoft's it stands for Microsoft Developer Network, and it's the source of information about all of the classes in the .NET Framework class library. And so we can see a short description of the purpose of the class. We can see its inheritance hierarchy. We can see some simple uses of it, its constructors that are available, any properties and methods that belong to this class, and then usually a paragraph or two of information about how it's intended to be used, as well as some examples written in different languages, including Visual Basic and C# and so on. But back up here to the top, for our purposes, the interesting thing here is that FileStream inherits from system.io.stream. So if we were to click on this, we would learn more about the stream class, and we can see that it derives from system.MarshallByRefObject, which then derives from system.object. And almost every class in the .NET Framework derives from system.object. It's the parent to every other class in the .NET Framework. So when we consider the system.io stream class, it provides a generic view of a sequence of bytes. Now, when we were using it in the file stream, we were working with a sequence of bytes that were stored in a file. But if you click this little more link here, it'll pop down later on in the web page, and we can see all of the classes that derive from system.io.stream. So we have some siblings to our system.io.filestream class that do things like work with database applications like Oracle or SQL Server. We have some that work with zipped files. We have some that work with memory streams, so bytes of data that are saved in memory. We have some that work with bytes of data that are streamed from over the internet, and so on. So what I take from that is this, that all of these classes will help you work with bytes of data. They're all similar because they all derive from the same parent, system.io.stream. But the way that they work internally and their function is just a little bit different. Some work with organized files, some work with unorganized files from across a network, some work with memory, and so on. Now, from a practical standpoint, once you learn about how streams work, generally you can expect similar behavior as a user of the stream class from every other stream class that you encounter from this point on. Instead of just memorizing the specifics about each of these individual classes, you can kind of fumble your way around by making associations about things you know about stream-based classes in order to use a new stream-based class in the future. All right, so hopefully that helps you see and relate how things work in the .NET framework, how everything is kind of related in some way, how they all derive from things which derive from things which derive from things, okay? So let's move on from there. As you can see in my car class, I have this public void print me method. Now, let's comment out this and let's go to the my truck.printme method as well. And let's run the application. And you can see they both print out their make and model. Great. But what if I needed this print me method for my truck to work just a little bit differently than the way that it works for car? So what I might do is this. I might need to override the functionality defined in the parent class's implementation of this method. So to do that, I'm going to do public override void print me. And then I'll do something like console.writeLine because I want to show towing capacity. All right, so I use this keyword override. Now, in order to make this work, I'm also going to have to add a keyword to my car class. The keyword virtual, and that basically means, hey, if you want to change this, go ahead. If you don't want to, that's fine too. We've got a base implementation for you to utilize, okay? So let's go ahead and run the application now, and you can see that we have two different implementations that are truck-specific implementation of the print me method prints out the make but also the towing capacity. Now we could also exchange this for the keyword abstract, which means, hey, you've got to change this. If you derive from me, you have no choice but to change this implementation. It's not really appropriate in this particular context because we still need to define an implementation for the car class. But that does bring up a larger issue. Maybe, stepping back for a moment, we shouldn't derive the truck class directly from the car class. Maybe instead we should make them both derive from a base class at a higher level. So let me approach it a little bit differently. So in this case, simply deriving from car may not quite be quite right for the truck class. Some properties and methods available in car may not be applicable to truck. Now, in our simple implementation, it doesn't really matter, but what if we had a more complex implementation? There might be some things about the car that's not appropriate for truck. So in these cases, the best thing that you can do is just back up a little bit and create a special type of base class called an abstract class. The difference between a regular base class like we have here with car and an abstract base class is that you cannot create an instance of an abstract base class. The only way it becomes useful is when there's a concrete version of that class that's created. So this is exactly how the stream class that we just looked at works. If we were to open it back up, we can see here that in the definition for the stream class, it's defined as abstract, which means we can't create an instance of it. So you'll see that some of its properties, when overridden in a derived class, it gets a value indicating whether the current stream supports reading. When overridden. So it requires you to override it. In other words, it's really just a template. It's not something that you can create an instance of. All right? It has to be overridden. In other words, stream is just a concept. A file stream, however, is something concrete that we can work with. So in the example that we've been working on up to now, we might choose to step back and create a new class called a vehicle base class, an abstract base class called vehicle, and then both car and truck, and then potentially motorcycle and bus would then inherit from it. So let's do this. Okay, so as you can see, now both car and truck derive from vehicle. Vehicle now defines the properties, and also it defines an abstract version of the print me method. Each class has to then override the abstract version of print me with its own implementation. Okay? So the antithesis of the abstract class is the sealed class, and it means that you cannot inherit from it. So you might never want another class to be able to inherit from your class. So you could mark it like sealed, like so. So if we ever tried this, we would get an error. Cannot derive from sealed type truck. Here are the main takeaways from this lesson. When you work with classes in the .NET Framework class library, be aware that almost every class is part of an inheritance hierarchy. If a class has a method or properties which are not readily apparent, it might be because it's inheriting the method or the properties from a base class or even an abstract base class. You might learn a lot about a given feature of the framework class library if you simply stop and take a moment to understand a little bit more about its parents that it's deriving from, or even take a look at its siblings, or even the children that inherit from it. Okay? You can certainly utilize inheritance in your own projects, but frankly that might be down the road just a little bit from where you're at today. I wouldn't worry about baking that into applications that you're attempting to build. However, perhaps you're going to work at some point in the future on a larger project, and it might make sense to make some library of business rules and logic that can be applied and shared across the entire application or across a family of applications within your company. In those cases, you'll undoubtedly be in need of a good inheritance strategy. And again, there are good design patterns for properly utilizing inheritance within your applications. So for now, your focus will probably be consuming and utilizing libraries that are created by others, especially those that are available within the .NET Framework class library. Now, the other takeaway from this is that there are a number of C# class and method modifiers that the creators of the Framework class library have used in an effort to guide you whenever you're using their classes. And by that I mean that they create abstract base classes or sealed classes, or use other modifiers in an effort to help nudge you, the consumer of those classes, in the right direction and to prevent you from doing something that would break those classes. So it forces you to use them in the way that the original creator intended for you to use them. It's just a matter of realizing, oh, I can't create an instance of this class because it's static. Okay, well then maybe I was trying to use it incorrectly. Or I can't derive from this class because it's sealed. Well, once you understand a few of those key terms, you'll be able to interpret the MSDN help like we did in this lesson, and understand more about what you are supposed to be doing with that class and what your options are going forward. Okay, so in the next lesson, we're going to finally discuss the purpose of namespaces, and we'll see you then. Thank you.